Hello everyone, this is Mr. Kissinger. This is fifth grade math module 3 review, lesson 4. So today we're going to learn how to subtract fractions with models. So we've been working with adding fractions, now we're going to work on subtracting fractions. And as a review, we're going to review the steps that you need to follow in order to add fractions, because our subtracting fraction steps are going to be very, very similar. So when we add fractions, we need to find the lowest common denominator. Then we need to rename the fractions. Then we need to add the numerators. And then we're going to leave the denominator the same. We never add the denominators together. And then we're going to finally reduce the simplest form. And if we look at our subtracting fractions steps, they're exactly the same except for number 3. And when we are adding fractions, we need to add the numerators. When we subtract fractions, we need to subtract the numerators. So it's the same steps, except we're going to be subtracting instead of adding. So if you can add fractions, you should be able to quickly transition into subtracting fractions as well. But we're going to start by using models to show how we subtract fractions. So the first one asks us just to do 3/4 minus 1/4. We have common denominators already. We don't have to change any. We don't have to find a common denominator. We don't have to change anything around. We're just going to show 3/4 minus 1/4. So if I have a rectangle here, and I have fourths, I've got 4 equal pieces, and I have 3/4. And then we're going to subtract 1/4. So we're just subtracting one of these shaded pieces. And I'm just going to put an X through this because we're subtracting it. Well, we have 2/4 left. Right here. We'll have 2/4. Then we just need to reduce. 2/4 is equivalent to 1/2. And as you can see, if we have just these two here, we're going to have half of our rectangle left. So that makes sense that we'd have 1/2. Oh, and we'll put that in our solution box, 1/2. Next, for number 2, we have 5/8 minus 1/8. So it's going to be the same thing. We're going to have a rectangle here, and we'll make eighths. So we'll make fourths, and then we'll cut our fourths in half. So we have 8 equal pieces. We have 1, 2, 3, 4, 5, and this is 5/8. And we're going to subtract. We always have one little eighth here. 1/8. So I'm going to cross out one of my eighths here. And that will give us 4/8. And again, 4/8, well, we have 4 out of 8 here. That's equivalent to 1/2. So again, our solution will be 1/2. Now, what if we want to do 1/4 minus 1/8? So first I'll have to draw my rectangle with fourths. I'm going to do this in a way that we can see both fourths and eighths here. So we have 4/4 here. We're going to shade one of them in. There's 1/4. Now I'm going to draw eighths with dotted lines. I'm going to cut these fourths. Because fourths we could cut them all in half, and then we have eighths. So when we have 1/4, we really have 2/8 here, and we're going to subtract 1/8 again. So I'm just going to cross out one of these eighths. And what do we have left? Well, we have like 1/2 left. But if we look at it in eighths, well, we have 1 out of 1, 2, 3, 4, 5, 6, 7, 8. We have 1/8 left. So 1/4 minus 1/8 is 1/8. That's as simplified as we're going to get it. So our solution is 1/8. Now we're going to need to get a little more creative as these go on. We have 1/2 minus 1/8. So we'll have 2 halves here. And if I have one of them shaded in, and I want to subtract, so this is 1/2, I want to subtract one of those little eighths like we had before. How am I going to get 1/8 out of that 1/2? How will I know? Well, first I need to make my denominators common, so I have to make them both the same, and I'll make them both into eighths. I can make this one into fourths, and then I can cut the fourths in half and make those into eighths. And now I can take away 1/8, and I'll see I have 3/8 left. So I have 3/8, and that will be my solution. I can't simplify that anymore. Let's skip down to number 7 here. We have 9/10 minus 2/5. So we have 9/10. 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. So we'll make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. And I have 9 of those tenths shaded in. So all but one of them. And I need to subtract 2/5. So I have like about that size. So when I want to subtract 2/5, I'm really subtracting 4/10. Because 2/5 equals 4/10. I'd multiply my numerator and my denominator both by 2. So I need to cross out 4 of these tenths. 1, 2, 3, 4. And I have 1, 2, 3, 4, 5 left. 5/10, that is. And 5/10 is 1/2. We have another 1/2 solution here. Because I can divide by 5, I would end up with 1. 5 divided by 5 is 1, and 10 divided by 5 is 2. So if we look at number 8 here, it says write an equation to describe the model below. Well, we have 2/3 here. We have 1/3 and 1/3. We have 2/3 minus 1/6. We'd have to make common denominators, so we'd have to cut these thirds in half and make them into 6. So we have 4/6 if we have 2/3. So really it'd be 4/6 minus 1/6. And I'll end up with 3/6, which will look like this. If we have 1/6, 1/6, and 1/6, but 3/6 is also 1/2. We have another 1/2 solution. We divide 3 by 3, we get 1. We divide 6 by 3, we get 2, and we'll end up with 1/2. So that is our lesson on subtracting fractions. If you guys think that these models are helpful, definitely use them to help you subtract fractions. If you can do it, feel pretty confident doing it without the models, you can start moving into that. In the next lesson, we're going to kind of move more into just subtracting our numerators and getting our solution rather than using the visual model. But like I said, I mean, if the visual model helps you, continue to use it. Well, we're all set for today. Thank you guys so much for tuning in, and I look forward to seeing everybody next time.